Okay, so this is the last part of the review of final sample final, right? So we stop at the part C of this question, right? Finding out whether a list contains any duplicate value or not. So part C, you're asked to solve this problem using divide and conquer paradigm. So how to do that? Right? So I hope by through working on midterm quiz number 3, you have got some intimate knowledge about that. So let's draw out our input, right? So we have an array of elements, and the left and right index of the array is given, right? So we want to find duplicates, or not find duplicate, has duplicate, right? So we are really writing a function that returns true or false value. So this is a has duplicate. So the parameter are the list, the left, and the right index. Okay, so when it comes to solve problem divide and conquer way, all right, so one rule that you can always apply first is cut it in half. Okay, so if it's a list of elements, cut in half just is easy, right? We just find out the middle index, right, by taking the average of left and right. Okay, so this will give us the index of the middle point. Right, so I'll mark here. So, and then that's a divide part. Conquer means I will then solve the two small problem resulted from this divide, right? So this is one problem, I will solve it. And a second smaller problem, right? So that means I want to call the same function to try to see if there's any duplicate in this part, in the left half of my array. So how do you do that? That's done by making a recursive call, right? Has duplicate. But since I'm only looking at the first half, the range of the index is from left to mid, right? So this one, remember, this is a true or false function. It will return something to me. It will return a value. So I'm going to store that value in R1, right? So R1 is either true or false. So think about it, right? If R1 is true, that means I have some duplicate value in the first half somewhere, right? Maybe there's 3 here and 3 here. So if R1 is true, do I need to continue? Actually, I don't, right? So if I have a duplicate, I'm just going to return true right away, okay? Because for the whole list, it also have duplicate, okay? So, but if R1 is false, right? We cannot return, right? We need to see the second half here from mid plus 1 to right, whether that have duplicate or not. So for that, we're going to make a recursive call. And the range of the index starts from mid plus 1 to right. Okay, so again, I'm going to keep the return value in variable R2. Right. Similar to before, if R2 is true, right, we can just return true and done. Okay. So if we didn't return, if we don't return from here, that means R1 and R2 are false. Right? I don't have any duplicate within the left half. I don't have any duplicate within the right half. But that doesn't mean I don't have any duplicate, right? So the thing is that maybe I have some value 10 here, and which also appear in the second half. So I need to look for such kind of duplicate that span both halves. So how to do that? Right? I need to compare every single element in the first half against every single element in the second half. Okay, so I'm going to change the color so it's a little bit easier to see. Right, so J will cycle through everything in the second half. I will cycle through everything in the first half. So every single I need to compare with every single AJ. So to write that code, it's something like that. Alright, so for I, start from left to mid, and for J, start from mid plus 1, right, so to right. If AI equal to AJ, return true. Okay, so if the whole for loop, nested for loop finish and without returning, that will signify that I don't have any duplicate in the whole list. So the whole function will go this way. Okay, sorry about this weird layout. Okay, so to recap, okay, so this demonstrates a typical divide and conquer paradigm. So a way to solve a problem, right? Find the middle point, divide the problem into two halves, right? But it's different from some example because in some case we only solve the left half, right? And the right half need to be solved only if we don't find any duplicates in the first half. Okay, so divide, conquer, and then this is so-called combining, all right? So usually there will be some leftover work to do to really solve the whole problem. Okay, so divide, conquer, and combine. Actually, there are 3 key steps that we have talked about in class. All right, so now let's move on to look at the analysis of this algorithm we just wrote, right? So the very first step is identifying what is the problem size, right? What is n representing when you, right? So we need to say, okay, let n be the length of list A from left to right, right? So which is really given by, that is n will equal to right index minus left plus 1. Okay, so from now on, whenever we talk about n, you should know it really can be calculated by using the 2 index this way. So let's write again to make our analysis easy, right? We want to be explicit about what Tn stands for. Tn is the number of steps in the total number of steps in the execution of has duplicate for list of length n. So right, so let's try to characterize T sub n, right, by looking at the code, right? So this is all we have in order to understand the running time. So I'm going to write on top of it, even though it will make it messy. First step, right, we find the middle point, right? So Okay, I realized something, right, I didn't do. That is base case, right? So if left equal to right, so then return false, right? There couldn't be any duplicate in a list with one element. So all the base case will translate into initial condition for the t sub n. So when n is 1, right, when your list contains one element, you have one step to finish the whole thing. Otherwise, all right, we are in the general case. So we have one step to find the middle point, right? And so let's for now just to say, make it clear that we only focus on worst case performance. Okay, so that means we will, after we call the first half, we call the first recursive call, which take this number of steps, right? Because the same function, right, has duplicate, so it's the same running time function. It's just that the input list is size n over 2. Okay, so the first call, because we're in the worst case scenario, so R1 will not be true, so we continue to go to the second half, right, which is another t of n over 2, right? And again, it will return false in our worst case performance, so we will come to the final merging part, combining part, which you, by now, I hope you will see that the running time for this one is n over 2 square. Okay. If you need help on that, feel free to raise this question in class tomorrow, why this part is n over 2 square. Okay. So, but for now, I'm assuming you know how to analyze this simple nested for loop. So let me just to simplify this part by combine the two t of n over 2 together, and this one will become n squared over 4. Okay, so there's 1 here, but that will not change the overall complexity. So let me now solve this one using master theorem. So I'm going to first convert it into the master theorems format, right? So it's always n a times t of n divided by some constant, right? And then some terms that are, we can capture the remaining term as n squared, okay? So drop constant, drop lower order term. So to apply master theorem, we identify, hey, our A is 2, right? Because every problem is to solve by solving 2 smaller problems. And B is the fraction, right? So how much we decrease the size of the problem, so by half, okay? And our D here for this problem actually is this one, right? D is 2. So, and then we were trying to compare D versus log B of A. Okay, so let's evaluate this one first. So log 2 of 2 is 1. So D on the other hand is 2, so it's less than. Alright, so this means T sub n, applying master theorem, case number 1, right? So the running time of the algorithm is that. So that's the running time for this divide and conquer way to solve the problem. So you can take a moment to say, to observe that it's no better than the first solution we have early on, right? It's still n squared. So for this particular problem, divide and conquer actually does not help, all right? So And the reason it really has to do with n square time it takes to combine the solution together, okay, which really result to the situation when d is greater than log b of a. So still, this 2 is the dominating factor that decides the overall running time. Alrighty. This problem. Actually, I think originally I have one more problem in the very end. Okay, so which I think is worthwhile to review. So I'm going to do it in the very end here. Given a sorted array of distinct integer, right? So actually I think given we have so much to talk about, I'm going to skip this. All right. So do not worry about solving brand new problem like this, right? If this appeared, it will only as extra credit. So if you're interested, if we have time tomorrow, I'm going to talk about it. But otherwise, don't worry. Okay, so this is the end of this recording.